دكتور. Sorry, I forget to put the mic. Yes. Assalamu alaikum again.
عليكم السلام.
عليكم السلام again.
So, please raise your hand. I want to see how many students around.
Okay.
Okay. So,
About health.
it's better if you close your mic. Okay. Now good. So, next time, or last time, sorry, not next time. Last time our subject was scaling and sorry, scope of rule and storage class. We already gave some introduction for and revision for functions and so on. Then we give the scope for the variables, which mean the place that this variable can be reached. And we saw that there is a global variable that can be reached anywhere in the program, and there was local variable, which is the variable of a specific scope, like a block and so on, and function variable, like a parameter variable, and it will be available for the whole function. And also we give this subject, which is storage classes, and as we saw, we can use some keywords to tell the compiler where this variable can be storage. That's why it's a storage class. And we said that the storage class, it's have effect on the life cycle of the variable. Okay, for example, when we make local variable static, its scope is still the block that it's defined inside it, or the function that it's defined on it, but its life stay until the end of the code. So if you call this function many times, this place many times, the old value of this local variable will stay in the memory because it's stored in some place called DS, data segment in place. So that's what we talked last time until we reach there's example here. For this example, you can go to, I don't have time to give you this example. However, it's same like all examples, but it's gather all the data or all the information in one example. You can go to our YouTube channel and okay, if you go to playlist Prog2, then you will find the videos, this for lecture 1 and this part 2. And here you will find this code. You can watch the whole video okay, for the lecture and also the previous lecture. Okay, anyway, now let's continue to week 2. I sent to you already the lecture note, but after I sent it to you, I removed some parts and keep it to week 3 lecture note because I feel it's little bit uh, big, yes. So I divide it into 2 lectures. So if you go to our group, you will find here week 2 lecture note. It's included also, it's include memory layout and also random generated, uh, okay, generating random number, and it's include recursive function. Recursive function, this part, I separate it into a different lecture. So I will make it on in week 3, this recursive function. So today we will take memory layout only and generating random number, and also I will give you homework 1. And homework 1 here, it's different than previous years. Don't bring same code as previous year. Previous year, it was a game also, but different game. In this year, I will give this homework, rock, scissors, paper game. Okay? We will mention it and how we can create it. Okay, so let's start our lecture note. Okay, so I have here just small problem because I use 2 screens. So let me just duplicate the screen. Okay. And okay, now it's working for me. Do you have any question? I hear someone speaking. Okay, let's continue. Okay, so as we can see here, this parts of the memory layout for C language. We mentioned it last time. We will speak about it in more details today, inshallah. So we have these parts in the memory for C language. So C language, uh, see the memory or use the memory as this parts. Text part, it's out of our job. Text part and environment part. So simply, this any variable related to the C environment and so on, and this will have the after compile the code, will have the binary code of the program. So it's not our job. Our job here in this parts, we have to know any variable, any function, and so on. It will be where in the memory, because different place in the memory means different way of managing the data, depending on the place that you stored or the program will store this data. The data will have life cycle different and will be used differently. That's why we have to know the memory layout for C, and we have to know our code, our variables will be stored in which place, because each place uh, will have different way for management. Okay, So first place, which is data segment. Data segment have two types, BSS and DS. Both part, it's a data segment. Okay. The difference here, uninitialized data will stay at BSS, initialized data will stay in DS. Both are data segment. Data segment. Both are data segment. What's the property of data segment? We said data segment keep the data until the end of the program. So any variable will be stored in the data segment. Its value will stay in the memory until the end of the program. What type of variable will be stored in the data segment? A global variable and static local variable, not any local variable, only static local variable. Okay. Local variable, when we define it as a static, it will be stored in data segment, but it will stay as local. So if we have function and it's have integer x, this x will be stored in the stack. But if we make this x static, it will be stored in the data segment. What's the difference? If it's stored in the stack, when you reach the end of the function, it will be removed from the stack. Next time you call the function, then you have a new copy, not the old copy. But if you make it static and it's stored in the data segment, this means it will stay in the data segment. You reach the end of the function, it will stay in the data segment. You call the function another time, you don't need to create it again because it's already in the data segment. You will use the old value. So its scope is still the function here, but its life until the end of the program. This is the data segment. Okay. We have also heap. Heap memory, it's a changeable memory. Its size will be changed. During the runtime, it's grow and up. Grow up, why? Because this place, it's empty place in the memory. So it's can grow. When you add data, it will grow and grow and grow towards this empty place. Okay. What type of variable will be located here? Variables and data that use dynamic memory allocation. So dynamic memory allocation, it's use some function that dynamically allocates the memory. We will take it, but not now, later when we take the pointers, because this is related to the pointer subject. Okay, about the stack, function variables, okay, function and its variables. The function itself, any data about the function, and its variable like parameter variable, local variable, all will be stored in a stack. We will speak about the stack, but each or every time you call the function, you will have like a part from the stack frame. So if you call function, this function, one time, it will have a frame. If you call it another time, it will not use same frame. It will take another frame and so on. That's why all data of the function, when you re-enter the function, you will not use it except if it's static, because it's not in the stack if it's static. If it's static, it will be stored in the data segment. That's different. How to force the system to use a specific place? Storage class, as we mentioned, like static. Okay, it's force it to, instead of a stack, to use the data segment. Okay, let's take one by one. Text segment, it's not important for our subject now, but to know it, simply, it will have the object code, the executable instruction of the code will be stored in the memory, because we know any program to run, it have to be stored in the memory. This is the data segment. Simply, you can read this, but for my point of view, just for your knowledge, your information about data segment. Okay, about text segment. About data segment, you have to know it. We have two types of data segment. Initialized data segment, DS, short name for it, DS. Uninitialized data segment, its short name BSS. BSS come from block started by symbol. Don't ask me why they name it like this. Doesn't matter for me. It's named BSS. Okay? Block started by symbols. You don't need to memorize all this name, just BSS. Uninitialized data segment. What's the difference? Data segment will have always global variable, static variable. If it's initialized or uninitialized, it's contain a global variable and a static variable. Then what's the difference? If we give initial value, the programmer, we give initial value for this global variable or a static variable, it will be stored in DS, initialized data segment. But if we give initial value as 0, or we did not give initial value, then it will be stored in BSS. For example, what's a global variable? Variables that created outside all the functions. So if we have function and we have the main function, okay, and you have variable, for example, integer x outside all functions like this, then if you did not give initial value for integer x and it's global, it will be stored in BSS. If you give initial value 0, also it will be stored in BSS. Why? Because if you give 0 initial value, or if you did not give initial value, it will be 0 in the memory. Why? Because if you did not give initial value, the default value by the compiler will be 0. So it will be stored in BSS. But if you give initial value, for example, if you give it initial value as 10, then it will be stored in DSS, data segment. Anyway, if it's in DSS or BSS, it will work same. Why it will work same? Because this data segment, it will, any variable stored in this data segment, its life will be from where you create this variable until the end of the program. Okay, stack. A stack will have any automatic variable. What's the automatic variable? Variables that will be allocated and deallocated automatically, like local variable of the function, parameters of the function, and any return value of the function. Any data related to the function, actually, it will be automatic variable and it will be stored in the stack. You can imagine stack as a box that have one place to add things inside it and take things outside it. So you have only one open place to add, or we name it push to the stack, and remove or read from the stack and remove from the stack. We called it pop. Okay, so push add to the stack, pop remove from the stack. Each time you call a function, you will have something called the stack frame for the function. So if we have the stack, each time you call the function, you will have a stack frame. Okay, if I have function 1 and I called it, you will have a frame for function 1. What inside this frame? All local variable data, parameter data, and return value. Okay, I call this function again. I call function 1 again. What will happen? You will not write over this one. You will have another frame for function 1. You call function 2, for example. You will have a new frame for function 2. As you can see, last frame, last function you will put in the stack will be on the top of the stack. So this first time, second time, third time. When you want to read from the stack, take from the stack, you will start with frame 3. So last frame, last data you put in the stack, it will be the first data outside the stack. Because like any box, when you put things here, last item you put in the box, it should be first item to be removed. That's why the stack we called it's leaf for order. What's the meaning of leaf for order? Last in the stack will be first out from this stack. Okay. This way, it's very important to understand it because it's how recursive functions that we will take next week is working. What is the recursive function? Recursive function, it's a function that call itself. Yes, so recursive function like this, the idea. When you have function, and inside this function, you call the function again. So it's become like a loop. The function call itself, then again call itself, again call itself, until a specific condition, then you exit this loop, this recursion. So when you call the function for the first time, you will have in the stack a frame. Then when you call it another time, you will have another frame, another time, another frame, and so on. When you finish, you start to read from last copy of the function because it's use a stack. So you will pop or remove last frame, last copy of the function in the stack. How it's work and how the recursive function work, sometimes they called it recursion, okay? We will mention it, inshallah, next week. So heap, shortly, heap, it's used to allocate memory at runtime. So it's dynamic memory. Dynamic means at runtime, not automatic. There is difference between automatic and dynamic, okay? Dynamic, it's allocate a memory at runtime. It's used when we use memory management function like memory allocation, reallocation, and free. All these functions, it's related to the pointers. Pointers, it's variables that have a star before it. We will take it, I think, after 2 weeks. Next week, recursive function. Then week 4, we will start with pointers. It's a very important subject. So later, we will return for this memory allocation when we take the pointers. Let's see this code that have different type of variables and see what the memory for each type. For example, here we have main function. Outside it, we have integer global. So this variable global, it's a global variable because outside all the functions, but it's not initialized. So it will be stored in PSS because uninitialized variable. Here pointer will not get the memory until we allocate the memory for it. So here, as you can see, pointer 1, we allocate the memory using memory allocate function. We will return for this at week 4. So this one use dynamic memory allocation, so it use or it will be stored, allocated in the heap. Look to this one, integer C. C, it's a normal variable, local variable. Local variable will be stored in the stack. Static variable and static variable. Static, it's not a normal local variable, it's a static local variable. So static variable will be stored in the data segment. This static integer I, it's have initial value, so it will be stored in TS. Static integer K, it's not have initial value, so it will be stored in PSS. It's not initialized, it's uninitialized static variable. It's stored in the PSS. Okay. So now we have another subject, which is random number. We can take a break until around 7 minutes until 11:10. Okay. So we can take a break for around 7 minutes until 11 and 10 minutes. See you. Assalamu alaikum. Okay. How many one around now? You can raise your hand, please. Okay. Let's continue. Random number generator. In C language, there is a function called rand. This function exists in the library std_lib, standard library, std_lib. You know, in the programming, in many cases, we need to generate a random value. This value could be integer, could be even random character or something like this. We can use this random function to generate number from 0 to rand max. What's this rand max? It's a constant value from this std line. It's a huge number, yes. But sometimes, as you know, we need this random value to be in a specific range. We will mention how to get a specific range. Anyway, rand function can be used to generate a random number. What if I want to generate a random character, for example, X or Y or Z? I want to generate one of this random character. Simply, you can generate random number, for example, and connect this number with this characters. For example, you said X equal to 1 or means 1, Y means 2, Z means 3, for example. So you can generate number from 1 to 3. If you get 1, then you consider it as X. If you get 2, consider it as Y. If you get 3, consider it as Z. So you can use this random function to generate a random number if you want a random number. Also, to generate a random number, and you can connect it to specific characters if you want to generate characters. Anyway, the function generate only numbers, okay? Some example of using this random function. If I want to simulate the coin tossing, you know, coin tossing, when you have the coin and throw it on the air, yes, you will get one of the faces that have head. When we was a kids, we was playing this game, or you can get a tail. There is two choices. Then you can say 0 means a head, 1 means a tail. So you can generate number 0 or 1. If you get 0 means you get head. If you get 1 means you get tail. So like this, you can simulate this coin tossing. Okay, what about dice rolling? You know this the dice, yes? This is the dice. You can also mimic or simulate this dice rolling. When you roll a dice, you get face that have number, white number like this. Maybe you have 1 dot, 2 dots, 3, until 6, yes? So to simulate the dice rolling, like someone rolls the dice, how to get the number randomly from the computer, you need to get random number from 1 to 6. But as I mentioned here, we have the random number from 0 to max. But in these two examples, as you can see here, we have in the coin tossing simulation, we have only 0, 1. In the dice rolling simulation, we have only 1, 4. To get a specific range for the random number, we will do something called the scaling. Okay, imagine with me. If you have any number in the world and you make this number mod 10, how many values you can get? Any number, for example, 2054, any number in the world. If you make it mod 10, you can get 0, you can get 1, you can get 2, until 9. For example, 1002 mod 10. What's the result? 2. Mod 10 means a remainder by 10. When you divide by 10, what's the remainder value? Okay, another example. 2009 mod 10. What's the result? 9. 1000. 1010 mod 10. What's the result? 0. So you will get always numbers between 0 to 10. 10 means to 9, sorry. Means if you have any number mod x, you will get value from 0 to x minus 1. This is the values that you can get. Okay, now again. Random give us numbers from 0 to max rand. Yes? If I want to make random value to give me numbers, for example, here 0, 1, then I have to do like this, rand. It will give me a number. Mod, how much? 0, 1 means mod 2. Random mod 2 will give me 0 or 1 because the maximum will be here 2 minus 1, which is 1. Okay, if I have, if I need 5 or 6 random numbers, if I need 6 random number, I will say random mod 6. Okay, random mod 6 will give me numbers 0 or 1. Generate a random number 0 or 1 or 2 or 3 or 4 or 5, which is x minus 1, yes? But look here, in this example, dice rolling, I need number from 1 to 6. What to do? only +1. So random mod 6 +1 means the minimum value will be not 0 this time, 1, and the maximum value will be 6. So in this case, I will get random number from 1 to 6. So like this, I can get a random value in a specific range to simulate any situation. Okay, again, this is the general rule for scaling. To get random number in a specific range, because this rand function will give you a value from 0 to rand max, which is maybe millions or thousands, but you need in a specific range, so you make it mod this range plus the shifting plus a. This is the general rule. To get a random number, you will make a plus rand mod b. What a, what b? Okay. Now look to this example. I need random number from 0, or let's say not from 0, from 5 to 20. To get random number from 5 to 20, I will make this mod 20. So rand mod 20. Okay, this will give me numbers from 0 to 20. Yes, but I need it from 5, so I will say 5 plus random mod 20. Of course, here, this will give me numbers from 5 to not 20, actually. From 5 to how much? To 20. This will give me to 19 before the shift. Let me just correct it. This will give me numbers from 0 to 19. If I need it from 5 to 20, I want to make this 0, 5, so I will add 5. 5 plus random. This will give me from 5 to 24, actually. So to make it correct, I will also minus 5. Okay, minus 5. So we removed this 5 plus 1. So even this one, it's not really accurate. I think we need to make it, however, this from a book, but I think we need to make it mod b minus a plus 1. It will be more accurate. This will give you random number from 5 to 20. Okay, I need random number from 0 and 1. It's simple. From 0 and 1. So this B will be the last width, the desired range, last width. And this A will be the first value. in the desired range. So from 5 to 20, this 5, this 20. From 0, 1, this 0, so we don't need it, and this 1, yes? No, 2. This is the last plus 1. P equal to the width of desired range plus 1. I will change it and send again this for you. So from 0 to 2, I will write it n equal rand mod 2 from 0 to 1. Why rand mod 2? Because this will give me 0 or 1. Okay, from 1 to 6, from 1 to 6, it's like this. One plus rand mod 6. Why mod 6? You said plus 1 here because you add this plus 1 here. So it's a plus 1 minus A to make it more correct. Plus 1 minus A. A, it's 1. So plus 1 minus 1 means it's a stay 6 as it. So let me change it here while I'm still remembering. So I will make it plus 1 minus A. This more accurate, more correct. So B, this the last range, plus 1 minus A, because if you add A here, you have to minus it from here. So now it's correct. Now it's correct. Now let's make it for any possibilities. Okay, let me just return to duplicate. Now it's more accurate. As you can see, okay, we need from 0 to 1, this A, this B. So 0, it's gone. Plus 1 minus 0, minus 0, which A0. This 1, so it's a plus 2. So it's rand mod 1. This mod 2, sorry, plus 1, this one. Mod 2. This to generate 0 to 1. Okay, if I need to generate from 5 to 20, then A is 5, B is 20. So it's 5 plus rand. Okay, B is 20 plus 1, 21 minus 5. So it's 16. Mod 16. Why mod 16? Because we add here 5. Rand mod 16 will give you 0, 1, 2 until 15. When you add 5, it will give you 5, 1, 5, 6, 7 until 20. Okay, it's clear. So this is the rule. A plus rand mod B plus 1 minus A. A is the first value that you need it. B it's the last value. So if we need to get a random value, if we need to get a random value between 4 and let's say 14, I need from you to write the rule. Okay, what we need, how to write this code if we need value from 4 to 14. You can write in the chat. You can write here in the chat. You know the answer. Yes, you correct. 4 plus rand mod 11. It's correct. Okay, so it's easy. This A, this B. So A here, which is 4 plus rand mod. Okay. B, which is 14 plus 1, 15 minus 4, so it's 11. Okay, let's see this code. This code here, okay, here we try to simulate the dice rolling. You know the dice, I just show you there. The dice, that cubes that have numbers on it. For example, 2, 4, 3, and so on. This one, okay, the dice. Here we roll the dice 20 times and see the random values. Okay. Let's run the code and see. We print 20 times a random value from 1 to 6. From 1 to 6. This part of code only to go one line down after each time. So when the counter reach 5, put S empty like this means go one line down. After 5 times, go one line down. Okay, so let's try this code. Okay, we have same code here. I want you to focus on the generated number here. Okay, look to the generated number. 6, 5, 6, 6 here. 6, 1, 6, 2, 5, 1, 2, 3, and so on. Look to it generally. Okay, I will run again. Same numbers, 6, 6, 5, 5, and if you look here, 6, 5, 6. Okay, but you said it's random. Run its 1,000 times, you will get same result. So from this, we see that this rand function, it's actually not a really random. It's pseudo-random or semi-random, but we need it to be for random. So if you run this code 100 times, you will get same result. This means same sequence of random will appear for you. Why? Because actually this function use something called seeds or seed value. Seed, you know the seed that like you plant it on the ground to get a tree or to get any planet, okay? So if you put a flower seed on the ground, you will get a flower planet. If you put apple seed, you will get apple. Same idea here. Actually, it's take a default seed here, or it takes seed generated from your code, like a hash code or something like this. So it use same seed, it will get same result every time, same sequence. Okay. But we can give different seed to get different value. Even in this code, if you can see here, we have same random code for dice rolling, but we roll it, we generate random number 6,000 times, and we have a counter here, normal variable, start from 0, and every time we check this random number, the face, it's only integer variable to get random number from 1 to 6. And we check if the random number 1, switch case, you can use if else statement. Here, switch case, we check the face, the random number, this one. If it's 1, we increase the counter for 1. This counter, we increase it by 1. If it's 2, so if we get random number 2, we increase the counter of 2 by 1. We increase third counter by 1 if we get to 3. If the roll is 4, same issue, we increase the fourth counter, and so on. If you look here to the result, almost for each random number, we get almost 1,000, almost very close to 1,000. Why? Because we have 6 possible random and 6,000 we roll, then almost you will give same sequence. That's why we get the possibility for 1, for 2, for 3, for 4, for 5, and 6. Same possibility almost. It's very close to 1,000, same possibilities. Why? Because I said random function, it's not actually a random. It's appear to be random, but it's pseudo-random. It gives you, it's repeating the same sequence of generated numbers. Okay, teacher. Okay, doctor, but we need random. You said it's not really random. I said to make it random, you have to get it different seed. Because if you keep it for the default seed, you will take the same sequence of numbers. To make it really random, you you will use, or you need to use, srand function before the random function. What's this srand function? It's a change the seed for the random function. So we use srand function before we use rand function. How to use it? Srand function, we give it a number. This number considers the seed that will be used by rand function. If we give different number here, we will get different sequence from the random function. Let's try it. Okay, here same code. I will give here, before using the random, here outside I will give different seed using srand, and I will give it any number. Now, for example, 5. This means we change the seed for this random function to this new seed, which is 5. Now run. We have different sequence. Yes, different number. We change the seed, give, for example, 88. We have different random sequence. Every time you change the seed, you will have different sequence. Okay, but I don't want to put the seed like this every time. I have to change the code and run it again. You have two ways. First way, you can, let me just close this code. You can use this way. You can read the seed from the user like this. Ask the user to enter the value of the seed, then depend on it, you generate. For example, we give seed, we get different value, another different seed, another different sequence, 6655556. Oh, sorry, I did not said use the seed. That's why we get the same. Okay, we read S from the user and we give it for the srand. Now it will work. Okay. So we have different values with different seed. Okay, but someone will say, why I should ask the user every time about the seed? It's not, it said it's not good practice. The user will not understand what's the meaning of the seed anyway. So we have another solution. We can get this seed, okay, from the code, generated from the code, using this one, using time function. What's this time function? This time function give you number of seconds. You can write it like this, time, and give parameter as null. Null, all of it capital letter, null. This function, time null, will generate or will give you number of seconds from now back to January 1970. Why January 1970? I don't know. Maybe the person who create the code create this function. Maybe he create it during 1970. I don't know. or maybe his birthday, his son's birthday. Doesn't matter for us. The matter for us, it will give you number of seconds from now back to January 1970. This means number of seconds now it's different than after 1 second, it's different than after another 1 second, and so on. Okay, so every time you will get different number as a seed for S random. This time function exists in the time library. So we can change this. We can add the time library, include it. Then instead of read this, we can take instead of S, we can do like this. We can set srand take the seed from time null. Time null, it will give you the second from current second back to 1970. So every second it will be changed. If the seed changes, the result will be a change. So as you can see, every time you will run, you will get different seed, you will get different sequence, as you can see. Now it's really random. Now it's really random because every second it will have different. Every second. Okay, every second you run, you will have different value. So always use this way. Like this, you have different seed, and you have to use it before you use the random. If you have for loop, while loop, just use this srand outside everything. Okay. Any question?
No, sir.
Okay, if you don't have any question, let's see the homework. Okay, the homework, it's to create a game called Rock, Caesar, Paper. You know this game, yes? Each two players, each one make a sign in using his hand. So Caesar beats the paper, and paper beats the rock, and rock beats the Caesar, and so on. How to create it? Okay. Until now, we take everything needed to create this game. You can create this game. You need two players in the game. First player, you will read the hand sign from the keyboard. So first player will give you, for example, R for rock, P for paper. Will press any letter from the keyboard, R, P, or S for Caesar. The second player must be a computer. The computer. How the computer can play? You can generate a random number from 1, 2, and 3. From 1 to 3. If the computer generates 1, this means I wrote it for you here. This means you will have to use random function. Okay, this means it's rock. If the computer generate 2, this means the computer play paper. If the computer generate 3, this means the computer play Caesar. Okay, rock, paper, Caesar. Okay, how to compare it with the player? You can convert this one to R2. You can convert it to B and 3. If the random number is 3, then player 2, the playing or the sign, the hand sign, equal S. If it's 2, then the hand sign, then you can compare this hand sign with the player hand sign. Your game must continue forever, yes, until player 1 press Q. If player 1 press Q means you quit the game. It's simple game and simple code. But here you must make 3 counters. You must count how many times player 1 win, how many times player 2 win, how many times they get a draw. They make same sign. Okay. After each round, each time they play, you have to print player 1 win how many times, player 2 win how many times, a draw equal how many times. How to calculate it? It's easy if a statement. Even I wrote it for you here. If player 1 is paper and player 2 is rock, then player 1 win. What's the meaning of player 1 win? You print on the screen player 1 win and increase the counter for player 1 win by 1. Else if player 1 is Caesar, player 2 is paper, also player 1 win. If player 1 rock, player 2 Caesar, then player 1 win. Else if they play same sign, then it's a draw. You have to print a draw and increase the draw counter by 1. Else, if not the player 1 win, and if not same sign, then player 2 win. You have to print the player 2 win, and you have to uh, uh, increase the counter of player 2 winning. Okay, that's all for the game rule. Here, you may write your code using a compiler or something, but only I need it as a handwriting from you. So after you try it using the compiler, write it, you have to write it on a white paper using your handwriting, then scan it, and upload it to OIS system. Okay, I will create the a tag for first assignment on. I did not create yet, but I will create on OIS system. Then you can submit your homework using this OIS system. I will send a video later for you to show you how to upload your homework. Anyway, you can start writing your homework. You still have time before uploading it. Um, and I need it only handwriting. Even if you use the compiler to write the code and check the code, after that, you have to use your handwriting. I will not accept C file or Word file, anything printing, okay? Not handwriting. Handwriting, scan it, then you can upload your homework answer. That's all. If you have any question, you can ask now. Okay, so if you don't have any question, then inshallah on Wednesday you have the lab. Inshallah, Salih Hoja will give you the lab. I will be around. I will open the meeting for you, but Salih Hoja will give you the lab, inshallah. So see you. Have a nice day. I will stop
nice
the
day.
recording.